Thank you very much. We'd like to go to questions, and one of the advantages of being the host, I get to ask the first question. So, just for my own personal interest, today the UK government announced a new strategy to find a community to host a long-term geographic storage facility for nuclear waste. Do you have any comment on the strategy for long-term storage in a geological facility and that of a community prepared to host it?
I mean, you know, I'm obviously not an expert in this area. The one thing I would say, though, is that I think that the debate about nuclear power is skewed illogically by this issue. Because as you know, as everyone knows, the nuclear waste problem is here. It's done, right? It comes from the weapons programs, etc., obviously in the 50s and the 60s. New build, as you know, as I know, is clean. It doesn't produce much waste. And I think that's often missed, because I get asked this quite a lot, because I support nuclear power because it's sensible. It's just demonstrably the best way that we have at the moment of producing base load electricity, of course it is. So I think that our PR challenge surely is to explain that new build doesn't contribute to the problem, really, a few percent. So you've got this problem, which is actually, you know, economically speaking, because we're one of the leading countries, if not the leading country, of the technology for this dealing with the waste, seems to me to be an entirely positive thing to be involved in, right? Seems to me. So I think it's tied up with the debate on new build as well, to be honest. So say we've got to deal with the stuff we've already got, and the new stuff is not going to cause a problem because compared to that, there isn't a problem. So that's what I would say about it.
Thank you very much.
I wish Oldham Council had bid for it, actually. Because clearly, Oldham needs an economic kick. Yeah. And you know, so in the geology, right, under the Pennines, we can actually just stuff it over the Yorkshire border, perhaps. But geology, right, I think maybe we should bid for it. Because that's the thing, isn't it? It's going to be a tremendous economic benefit to the area. To have facilities like that.
Thank you very much. Questions from the floor? I have a microphone. Nothing about the graph?
You don't have to ask about physics, you can ask about anything you want. Yep. Within reasons.
Hello. Hi. Emma Brooks, I'm from DHL Supply Chain. But I did physics in the first year at university, so some time ago. And my question is, where is maths telling you that the next understanding is going to come from?
So it's actually there's quite a lot of stuff, obviously, that I kind of skipped over. But one of the big things, so in here in this prediction, there are two extra elements in the predictions which we've seen but we don't understand, called dark matter and dark energy. So in fact, 96% of the energy, or 95% of the energy in the universe is not in the form of the particles that I described. So the particles I described are the ones we've discovered. We see gravitation, very strong evidence through the way that galaxies spin and the way the universe evolves. But other particles that are not those, but subatomic particles which we call dark matter, 5 times as much of those as there is of the other stuff that makes up us. And we're on the verge, probably, of finding out what that is. There are some hints from some underground experiments that could have been, we could have seen these things colliding. They'll be in this room now, dark matter particles. The galaxy is suspended in the back of them, really. So they're all over the place, but they interact only weakly, but through the weak force. So we look for them colliding with detectors, which they would do occasionally, the same way that neutrinos bump into things occasionally. And there's some evidence, but it's not significant enough yet, that maybe we've seen them. And also the LHC has a chance of making those more exotic forms of matter. So that seems to be, if you were to guess, around the corner. It's certainly there. I think nobody disagrees with that statement. It's in those predictions. So it's surely there. So that might get sorted out within the next few years, actually. Dark energy, though, that's about 65% of the energy, 67% in the universe. That's a baffling thing. Because what was discovered about 10, 12 years ago now is that the universe is accelerating in its expansion. So you would think, everybody thought, that the Big Bang and everything accelerates away from each other, and then because gravity is an attractive force, it slows down the expansion rates of the universe. But the expansion rate is increasing, right? Several measurements tell us that, and that's in there as well. So it looks like it is.